Hello guys, welcome back, and in today's video we are going to look at the simplest hydrocarbon family, which is called alkanes. So first things first, alkanes are saturated hydrocarbons. So in exams, when you're asked about what makes a saturated hydrocarbon, you should answer that they contain hydrogen and carbon only. Okay, for example, methane, CH4. This is a hydrocarbon because they contain hydrogen and carbon only. But if it was ethanol, for example, CH3CH2OH, this is not a hydrocarbon because why? Because it contains an oxygen atom. This is an organic molecule. And they contain no other elements. Okay? So in alkanes, which is saturated hydrocarbon, they don't have any other elements. For example, methane or ethane. Okay? They don't have any other elements. And alkanes are saturated hydrocarbons because they contain only carbon to carbon single bonds. For example, if it was methane, they contain only C to C single bonds, and they have no double bonds or no triple bonds. Okay, if it was ethane, it would be like this. There is no there is no double bond or triple bond. So that is why alkanes are saturated hydrocarbons. So vice versa, what are unsaturated hydrocarbons? Unsaturated hydrocarbons contain carbon to carbon double bonds. So these are the first five members of alkanes, which are methane, ethane, propane, butane, and pentane. All of these alkanes are called straight chain alkanes because why? You cannot see a branch. Okay, this is all a straight chain alkanes. And the display formula is showing all the bonds. You should practice drawing these straight chain alkanes. Okay. So isomers, very important topic here. Isomers are compounds which have the same molecular formula but different structural formula. What it means by that is that since it has the same molecular formula, pentane is what? C5H12. Okay, so I'm going to first draw the first isomer. I can simply draw a straight line, okay, a straight chain. 1, 2, 3, 4, 5. Notice how I draw my longest chain first. Okay, so I draw my longest chain first, then I'll add in hydrogen. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's C5H12 as I was mentioning. Okay, alright, so since you don't have anything special here, the name of it is, all of these are single bonds, so this is going to be ending in alkane, ane, and since this is 5 carbon atoms, it will be pentane. Alright, so if I'm going to draw an isomer, a tip that I can tell you is you can either draw shorter or longer chains. But right now, this is my longest chain and I can draw something longer than this. So what I'm going to do is I'm going to try to draw something shorter. Let's say, since I have 5 here, I'll try to draw 4 only. 1, 2, 3, 4. So, can I add 1 here, sir? So you can really add 1 here because why? If you do it that way, your longest chain will still be 1, 2, 3, 4, 5 because they are still connected to each other. You can't do that, okay? So that's why your longest chain has to be different. Let's try putting it here. So where's your longest chain? Your longest chain is either 1, 2, 3, 4, or it can be, give me a second, 1, 2, 3, 4. So no matter what it is, your longest chain is 4. Okay, so let's stick to the blue one here. Okay, all right. So, oh, sorry. Okay, so this will be CH3, and this will be CH2, and this will be CH3. This will be CH, and this will be CH3. Okay? Alright, so this is a structural formula. Alright, so I know that my longest chain is 1, 2, 3, 4. So it's going to be but, and I only have single bonds here, so it will be butane. So my branch chain right now is CH3, which is the methyl, and I only have one of it, so it will simply be methyl. But I need to tell where my methyl is, so either I count from the left, but let's see what happens if I count from the right. 1, 2, 3, 4. I want my name to have smallest number as possible, so it will be 2-methyl butane. Alright, so for the last one, what I'm going to do is, I'm going to draw a shorter chain this time again. So let's try drawing 3, okay? 1, 2, 3. So, can I put this here? If you put this here, this will simply be what? 1, 2, 3, 4, butane, okay? So let's try putting your branch at different places at your branch chain. So I'll put one here, CH3, and I'll put one here, CH3. So let's try to see what is our longest chain this time, okay? So my longest chain can either be this one, 1, 2, 3, or it can be this one, okay? Or it can be this one. So no matter which one I choose, my longest chain is only 3 carbon atoms, okay? 1, 2, 3. So I will name my longest chain first. So it will be propane, propane. So now I have two attachments, which is this one and this one. And I'm going to count my main root, so it can be 1, 2, 3. If I count the other way around, it will still be 1, 2, 3. So no matter what it is still going to be at 2. And since I have two groups, it will be dimethyl. Alright, and since it's at 2 and there's two of them, 2, 2 hyphen dimethylpropane. Notice that you need to put a hyphen between a number and a name, okay? And you don't need any space between dimethyl and propane at all. Alright. So properties of homologous series. So alkanes are homologous series because why? They have similar chemical properties because they have the same functional group. In this case, it is carbon to carbon single bonds, okay? And then they have a trend. They show a trend in physical properties. They can be described by the same general formula, which is CnH2n plus 1. And they are different from one member to the next by CH2 unit. So it's very important for you to study this by heart, I would say, because when they ask you what are some of the properties of homologous series, I need you to be able to answer this properly and precisely. Alright, so a trend in physical properties, okay? They show a similar trend in physical properties. So the first 4 alkanes, which is methane, ethane, propane, and butane, all of them are gases at room temperature, okay? Because why? Their boiling point is much lower than our room temperature. That's why they exist as gases. And all the other alkanes you will see at IGCSE are going to be liquids. And sorry, hydrocarbons only become solids at about carbon 18. Now, why does the boiling point increase gradually in homologous series? It's because the molecules increase in size. If you think about it, this is going to be your methane molecule, okay? This is your methane molecule, and this will be your ethane molecule. So obviously, your ethane molecule is going to be larger than your methane molecule, okay? This molecule is going to be so much larger than your methane, so that's why the boiling point increases. And since the size of molecules become bigger, the intermolecular forces of attraction between them also increases. That's why you will need more energy to separate them, okay? That's why you are going to need more energy to break the attraction between molecules, and hence the boiling point gradually increases. In exam, they might ask you to do something like, oh, the boiling point of methane is much lower than, let's say, ethane. Why is it that? Okay, and you can explain that the molecule of ethane is larger, and that's why intermolecular force of attraction is larger, and you need more energy to break them, and that's why the boiling point is going to increase.